Okay, so here we are. I'm doing a demo of the AVR Micro, which is here, AVR-atmega8, connect to the AVR ISP-MK2, which is the ISP flasher, connected to the laptop via USB, and that is connected to the AVR board is connected to the power supply, the 5-volt power supply, of course, fast to fire power, and the AVR board, which is here, is connected to the XBee, which the AVR board exposes the receive and transmit lines from the UART to the XBee, which is a wireless device, a wireless modem, and it sends back data from the robot, which is supposed to be the big project, to the laptop, so I can monitor all the different readings and what's going on in the robot in terms of status, and perhaps also giving it control messages back to the robot. So between these two devices, which is the XBee on the laptop and the XBee on the actual robot, connected here just as a simulation, as an example, and this is being sent from and connecting via the AVR ISP-MK2 to the micro, the AVR-atmega8, sending that code, flashing it, and then sending it to the actual laptop here via the USB XBee, which is here, wirelessly, over the air. So the code that I'll be sending is here, which is a kind of a demonstration of the actual program that just sends messages back and forth from the robot. Right now it's just sending in a forever while loop and spitting out a counter to just count from 0 to whenever, just to show that it's sending back data, and that is being sent through the UART, which is connected to the XBee USB device, the XBee device that's connected to the UART itself, and then that data is being read by the terminal, which is here connected to the laptop XBee USB device through COM11. So here it goes. Once I program it, I'll just flash it here, and then immediately it starts sending the XBee data, or the actual data that's in the micro, which is just counting from 0 to whenever, and this is happening wirelessly. So this is kind of a sampling of, and a demo of the XBee device, and what I'll be working on next to refine the odometry data back from the robot, and giving it the different control messages in order to navigate and get around this environment properly, and making sure that it's doing the right thing. So this is mainly for debugging purposes, wirelessly. Previously I've had actual cable connected to the robot, to the laptop itself, and getting messages back and forth, which is, it's okay, but it's sometimes it gets tiring because you're not able to disconnect the robot. The robot is tethered through a cord, so wireless makes it a lot easier because you can move around and then send messages back and forth, and being able to just get the robot in a certain environment and then not having to have that tether. So this is where we are. Okay, so stay tuned for the next video or demonstration program or update to my blog, and we'll see you soon. Okay, thank you.